Hello everyone. Today we will learn about divisibility rules. So divisibility rules tells us if a number is completely divisible by another number or not. It also tells us what will be the remainder if the number is not completely divisible. So let's see. Let's start with rule of 2. So rule of 2 states that if the unit place of a given number is even, it is divisible by 2. That means if the last digit of a given number is even, then the number is divisible by 2. Let's take some example. 484, the last digit is even, hence it is divisible by 2. 485, the last digit is odd, hence it is not divisible by 2. Now what will be the remainder of 485? So remember that remainder of any number is all natural numbers less than the number used to divide. So in this case, 2 can always have remainder as 1 and only 1. Now let's see rule of 4. Remember, 4 is 2 to the power 2. So rule of 4 states that if the last two digit of the given number is divisible by 4, then the given number is divisible by 4. Okay. So what it means? Say, let's take one example, 6, 7, 6, 4. Is this number divisible by 4? We will take the last two digit. Okay. So if the last two digit is divisible by 4, the complete number is divisible by 4. So as we know that 64 is completely divisible by 4, hence this number is divisible by 4. Let's take another example, 8, 5, 4, 5, 0, 0. Is this number completely divisible by 4? Also remember, if the last two digit is 0, in that scenario also the number is completely divisible by 4. So here in this case the last two digit is 0, hence we can say that this number is also completely divisible by 4. Now let us take one more number, large number, 85450000000. Is this number completely divisible by 4? Now again just see the last two digit. If the last two digit is divisible by 4, or if the last two digit is 0, the number is completely divisible by 4. Say for the same number, the last digit is 2. What will be the remainder? Just divide the last two digits by 4 and the remainder will be 2. How? So we take the last two digits 0, 2 divided by 4. Remainder will be 2. Now let's see rule of 8. Now we know that 8 is 2 to the power 3. So it says that if the last three digit of the given number is divisible by 8, or if the last three digit is 0, in that case that complete number is divisible by 8. Let us take one example, 45640. Is it divisible by 8? We just need to take the last three digit. So last three digit is 640 by 8, which is completely divisible. Hence this number is completely divisible by 8. Let us take another example. 4, 5, 6, 4, 6. Is this number completely divisible? So we know that it will be 6, 4, 6 by 8. So we know that if we divide this one, we will get 6 as remainder, because 8 8 is 64 and then we get 6 as remainder. Now what are the possible values of remainder for 8? So it can be 1, 2, 3, 4, 5, 6 and 7. These are the possible values of remainder for 8. Possible remainder of 8. Now let us take one more example. There is another number given, say 4, 5, 6, 4, 6, 0, 0, 0. Okay. Is it divisible by 8? See, the last three digit is 0. And we know that if the last three digit is 0, the number is divisible by 8. Now let's see rule of 16. 16 is 2 to the power 4. So we see a pattern here. Okay. So if the last 4 digit is divisible by 16, then the complete number is divisible by 16. Similarly, if the last 4 digit is 0, then the complete number is divisible by 16, right? So last 4 digit or last 4 zeros, right? Possible remainders are 1, 2, 3 up till 15. Now say rule of 32. So 32 is 2 to the power 5. So we have understood the pattern. That means if the last 5 digits are divisible by 32, then the number is divisible by 32. Also, if the last 5 digits are 0, then the number is divisible by 32. So similarly, we can define rule for 64, again 2 to the power 6. So if the last 6 digit is divisible by 64, in that case the complete number is divisible by 64. Or if the last 6 digits are 0, then the complete number is divisible by 64. Now let us define rule of 3. So rule of 3 is very easy. If the sum of the number is divisible by 3, the number is divisible by 3. So if the sum of digits of the given number is divisible by 3, then the given number is divisible by 3. Okay, let us take one example. We have, say, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. If you take the sum of all these digits, we get sum is 45. Now we know that 45 is divisible by 3, hence this is divisible by 3. You can also do one thing. If this, say for example, if the resultant is large enough, then to simplify it, you can take again sum of all the digits. Now in this case, we take sum of digit 4 plus 5, that is 9. Now 9 is divisible by 3, hence we can say that the complete number is divisible by 3. Now let us understand rule of 9. Now the rule of 3 and rule of 9 are exactly the same. Okay. In this case, if the sum of the digits of the given number is divisible by 9, then the given number is divisible by 9. Let's take the same example once again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. The sum is 45, which is divisible by 9, as this is divisible by 9 as well. Now, if you take the sum of the digits, okay, of the result from the previous summation till single digit, you will find that if a number is divisible by 9, the sum of the digit till single digit will always be 9. Say in this case also 4 plus 5 is 9. Say 72. 7 plus 2 is 9. This is divisible by 9. Now let's take another example. 2, 4, 5, 8, 8. So we get 27. 7 plus 2 again 9. So this number is also divisible by 9. Now let's take another example number 2, 4, 5, 8, 7. Here the sum is 26. Now 2 plus 6 is 8. In this case, the remainder will be 8 when divided by 9. So this number is not completely divisible by 9. Okay. Now let's understand one of the most important rule, rule of 11. So rule of 11 states that if the difference of sum of the digits at odd places when counted from right and sum of the digits at even places when counted from right is either 0 or multiple of 11. In that case, the given number is completely divisible by 11. Let us take some example. So say for example the given number is 1, 4, 5, 7, 8, 2, 4, 5. Now to see whether this number is completely divisible by 11 or not, we will count all the odd places from and add all the odd places. Sorry. So to see if this number is completely divisible by 11 or not, we will take the sum of all the digits at odd places when counted from right. So the numbers are 5, 2, 7 and 4 minus sum of the digits at even places when counted from right. So this will be 4, 8, 5 and 1. So let's count. 5 plus 2 is 7, 14. 14, sorry, 5 plus 2 is 7, 7, 7, 14. 14 plus 4 is 18, right? Minus 8, 4, 12, 5, 17, 1, 18. So here the remainder is 0, which means this is completely divisible by 11. Let us take another example. 9, 8, 7, 9, 8, 1, 6, 1, 0. Again, let us count it, all the odd digits at the odd places and add them. So 0, 6, 8, 7 and 9. What is the sum? 30. Now count the digits at the even places from the right and add them. 1, 1, 2, 11, 19. Here the remainder is 11. And 11 is completely divisible by 11. Hence this number is divisible by 11. Let's take another example. 8, 2, 4, 0, 7, 1, 9, 5, 9, 7, 0. Let's see if this number is divisible by 11 or not. So let's take sum of the digits at all the odd places when we count from right. So 1, 2, 3, 8. Okay. This will be this, this. So let's take the sum. 0, 9. We get 37 minus 15. This gives 22. And 22 is completely divisible by 11. Hence this number is completely divisible by 11. Let's see few more rules. Rule of 6. I am not telling about rule of 5 and rule of 10 because it's very easy. Rule of 5 is any number which ends whose unit digit is 0 or 5 is divisible by 5. And for rule of 10, any number whose unit digit is 0 is divisible by 10. So let's see rule of 6. Now we know that 6 is a composite number. We studied this in the last episode. Now we will divide this composite number into two parts, or we'll take the factor of this composite number in such a way that it forms a co-prime number. So we can write 6 as 2 into 3 and we know that 2 and 3 are co-prime. Now for a number to be completely divisible by 6, it has to be divisible by 2 and 3. And we know the divisibility rule of 2, the number should be even, and we know the divisibility rule of 3, that sum of the number should be divisible by 3. So let's take one example. 1, 2, 3, 4, 5, 6. Is this number divisible by 6? Yeah, the unit place is an even number. So this number is divisible by 2 and sum of the digit is 21 and 2 plus 1 is 3 and 3 is divisible by 3, hence this number is completely divisible by 6. Similarly, rule of 12. Rule of 12 states that we divide the number 12 into two coprime numbers. So 4 and 3. This is coprime number. So if any number is divisible by both 4 and 3, the number is completely divisible by 12. And we know the rule for 4. The last two digits must be either 0 or should be divisible by 4, and the sum of the number must be divisible by 3. In that case, the number will be divisible by both 4 and 3, and we can say the number is divisible by 12. Let us take one example, 2340. So last two digits is divisible by 4 and sum of the number is 9, which is divisible by 3. Hence this number is completely divisible by 12. Similarly, rule of 15. We can say 15 equals to 5 into 3, and 5 and 3 are co-prime. So any number divisible by 5 and 3 respectively will be divisible by 15 as well. Rule of 18. 18 we can write as 9 into 2. We know the divisibility rule of 9 as well as 2. So any number that is divisible by 9 and 2 respectively is divisible by 18 as well. Rule of 24. 24 can be written as 8 into 3, and 8 and 3 are co-prime. Rule of 44. 44 can be written as 11 into 4. Rule of 72. 72 can be written as 9 into 8, and 9 and 8 are co-prime. Similarly, rule of 99. 99 can be written as 11 into 9, and both are co-prime. Similarly, if you say rule of 132, so 132 can be written as 12 into 11, and 12 and 11 both are co-prime. Now 12 can be again written as, we know here 12 can be written as 4 into 3. So we can write 3 into 4 into 11. So if a given number is divisible by all three digits, all three numbers, 3, 4 and 11, then that number is divisible by 132 as well. Okay. Now let us understand the divisibility rule of 7. Now you need to understand that 7 is a prime number. So to find or derive the divisibility rule of a prime number is little complex. Let's understand the rule for 7. So what we need to do is, of the given number, take the last digit of the number. Now, after taking the last digit of the number, double it. Now, subtract this doubled number from the rest of the number. Subtract this doubled number from the rest of the number. Now 4. If the result is divisible by 7, then the original number is divisible by 7. Now, if still, we get after subtracting, if the value is still large, we need to repeat the first 3 process once again. Till you get a number which is small enough. Let us see one example. 203. So is 203 divisible by 7? We will take the last digit of the number and double it, which is 6. We'll take the remaining number, which is 20, and subtract the double of the last digit, which is 6. What we get is 14, and 14 is divisible by 7. Hence 203 is also divisible by 7. Let's take one more example. 845. Take the last digit and double it and subtract it from the remaining number. So the remaining number is 84. Double of last digit is 10. We get 74. Now we know that 74 is not divisible by 7. Hence this is not divisible by 7. Let us take one more example. 72184. Take the last digit of the number. The last digit is 4 and double the number. So double of 4 is 8. Take the remaining number and subtract the doubled number from rest of the number. So 7218 minus 8. We get 7210. Say this number is still large enough. What we can do? 721, double of 0 is 0 only. So we get 721. Say 721 is still large enough. What we can do? Take the last digit and subtract it from the remaining number. Remaining number is 72. Double of last digit is 2. We get 70. Again, we can do the same. Take the last digit, double it, and subtract it from the remaining number. Remaining number is 7. Double of 0 is 0. So we get 7. Now this is divisible by 7. Hence we can say that the given number is divisible by 7. Thank you.